Hello, ladies and gentlemen. This is Miss Skokin. We're back in Chapter 1, and this time we're in Section 2, Displaying Quantitative Data with Graphs. I'm going to ask you to please turn off the video so you can read the objectives, vocabulary, and essential question, and then turn the video back on so we can get started. All right, our first question is which graphs are appropriate for quantitative data? We remember that for categorical data, we're going to only use bar graphs and circle graphs or pie charts. For quantitative data or numerical data, we're going to be able to use 4 different types of graphs. The first one is called a dot plot. The next one is called a stem plot, sometimes called a stem and leaf plot. Then we have the one that we're probably going to use most of all, which is called the histogram, and the box plot, which we will also be using a lot. Some of you may have seen some of these graphs before. So what we're going to do to start with is we're going to graph from our class data a dot plot on the number of hours our classmates slept on the night before we took the survey. Now the first thing we need to do is figure out how to scale our data, and what that means is we need to know what the minimum value is and what the maximum value is, and we have to decide, are we putting in half-hour values? Now our data was requested by half-hour values, so it makes sense for us to put it in that way. So first things first, let's go ahead and draw our number line. Our minimum value appears to be 3.5 and our maximum value appears to be 11. Okay, so we start out with our scale, and you can see that my scale goes from 3.5 hours to 11 hours, the two extreme values. We know we need to label this, so we're going to call this sleep hours right under the axis, and then we're going to start accumulating our data, and that means we're going to count how many we have at each value, and we're going to draw dots for each one of those individuals. So we have one dot at 3.5, we have one dot at 4, we have 1, 2, 3, 4 dots at 6, and then at 6.5 we have 1, 2, 3, 4, and I'm going to count the person who answered 6 to 7 hours as a 6.5. So we end up having 1, 2, 3, 4, 5, 6 at 6.5. 1, 2, 3, 4, 5, and 6. And then for 7 hours, I'm going to count the 6.75 as a 7. That person did not answer the way that they were supposed to. So we're going to have 3, 4, 5, 6, 7, 8 for 7 hours. Now notice that our dots have to be drawn in straight lines so that we can get a good sense of the shape. And mine are not perfect, but what I mean by that is we would have all of these on a line and all of these on a line, etc., so that we can get a good sense of the shape. All right, back to our graphing. For 7.5, we've got 3. So 1, 2, and 3. For 8, we've got wow, I don't know. I'm going to tell you to pause the video, go look at the data, and finish up the graph, and then turn the video back on when you're ready. Okay, so we have finished our dot plot, and now we need to describe it. So when we analyze data, remember, what are we looking for? There are a few things: shape, center, spread, and we'll talk a little bit more about each one of these, and outliers. G-SOX is the way I want you to remember this, and G is for gap, so that's the only one missing here. When it comes to this distribution, and if we want to describe it, as far as the shape goes, we would say we see a unimodal shape, which means one peak, and it is definitely left skewed. And when we're looking to see what the skew is overall, what we would do is we would look at where the peak is, and you can see this is the tallest column at 8 hours of sleep, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 rows to the left, and 1, 2, 3, 4, 5, 6 rows to the right. So more rows to the left means the tail is on the left skewed. We'll talk a little bit more about that on the next page. As far as center goes, we would either be looking for the mean or the median. In this case, we have a skewed distribution, not symmetric, so we would be using the median. And the median, because we have, I think it's 36 pieces of data, the half of 36 is 18, so it would be between the 18th and the 19th value. And that would put us in the 7 column, the column of 7 hours. That's where the median would fall. In terms of spread, we haven't really talked enough about that, but for right now, let's talk about the range of values. That's one measure of spread, actually the one that we will use the least frequently, but that would be from the maximum of 11 to the minimum of 3.5, so that would give us a spread of 7.5. And then in terms of outliers, we have two numbers at the low end, 3.5 and 4, and one number at the high end, or 11. You know, we don't know if those are outliers or not, but they definitely seem to be a departure from the overall pattern because our data is mostly clustered between 6 and 9 hours. We will learn more about finding outliers in a little bit. Once again, GSOCs stands for gaps. So in this case, on that first graphic, you can see that we have a gap right there in our data in the puppy weight change between 1 and 1.5, it looks like. So a gap is exactly what it sounds like. There's a gap in our data. In terms of the first S, we know it stands for shape. And you see we have two little mice here, and it's going to help you remember that if we've got our coordinate plane like this, and we have a tail on the left, that's left skewed. And if we have the tail on the right, that is right skewed. Okay, so that little mouse is to help you think about where is the tail or the low frequency of data. That's shape. That's one way to look at shape. Another way to look at shape is how many peaks do we have. And you can see on this one we have one peak, so this is what we would call unimodal. On the next graph we have actually two peaks because it looks like we have two different kinds of data here. We would call this one bimodal. Now we typically see this when we have two different groups that do have different number characteristics, and we put them on the same graph. On the third one, you can see that we have 3, so rather than call that trimodal, we just call it multimodal, and it means we have more than 2 peaks. So far, we've got the G, we've got the S, next is O for outlier in our GSOCs. And outliers, once again, these are departures from the pattern. So you can see over on the right-hand side, we have 3 data values that are a little bit far away from the big cluster of data that we have on the left-hand side. We haven't learned how to test for outliers yet, but so far we can see if it's a departure from the overall pattern, we suspect that it might be an outlier. Okay, next we come to C for center. And the measures of center that we will use will be the median and the mean. The median is the center value, and in the old days we would knock a number off the bottom and off the top and work our way towards the center. But because we might have hundreds and hundreds of pieces of data, we're not going to do it exactly that way. What we're going to do is we're going to find the middle by figuring out how many pieces of data we have and going to that middle value directly. And that will give us our median. In terms of our mean, we add up all the different values and then divide by the number of numbers that we're adding. And that gives us the mean. We sometimes call that the average, but we're not going to anymore. We're going to call it the mean. We're going to be a little bit more precise. And then our last graphic is representing spread. And spread, I want you to just notice, again, spread means variability. And variability means how much does the data differ from the whole rest of the data. So if we take a look at this graphic, we can see that the minimum and maximum values, it's hard to tell on that top one, go for a fairly long width, and at the bottom graphic it's very narrow. You can also look at it this way, kind of where that first standard deviation occurs, and again this is very narrow on the bottom one and very wide on the top one. So large spread means more variable, means you're going to have a longer range or a larger standard deviation or a larger interquartile range. Again, we'll talk more about those coming up soon. We've come to a check for understanding, and I would like for you to work on that on this page. When you upload your file, I will be looking for these. Remember that you can check your answers at the back of the book, because all of the answers to the check for understanding exercises are included in your solution section in the back of your textbook. We're going to look at comparing distributions now. And we're going to look at our data in the AP Statistics classes, and we're going to graph, we're going to make a back-to-back dot plot. We need to figure out, first of all, what our axis needs to include. And if we look at our data, the minimum number of siblings is 0, which makes sense. And the maximum number of siblings that we have is 3. So we're going to set up our axis first. We can only do a comparison of 2 things at a time at this point. So what we're going to do is we're going to set up on the left the earlier data and on the right hand side the later class period. So go ahead and draw in the dots. Remember that your dots need to be in perfect rows, and I'll see you back in a minute when we've written our data down onto our graph. Now that we can see our data graphed, it actually looks very similar in the 2 classes, with definitely the most frequent number of siblings being 0 in both classes and not far behind 1 sibling. Pretty uncommon to have 3 siblings. To do a good job of a comparison, we need to use describing words. So we're going to go ahead and describe the 2 distributions and compare the 2 distributions. So let's use socks as our guide, remember. Shape, outliers, center, and spread. We're not going to worry about outliers right now, but we are going to start out with shape. Shape is something that both distributions have in common. They're both right skewed, with the high frequency on the left and the low frequency on the right, and unimodal, meaning 1 peak. When we calculate the mean values of both, we see that the earlier class has a smaller mean compared with the later class that has a larger mean. We include the comparison words, but we also include the numbers. In this case, it's noteworthy that both classes have the same median of 1 sibling, so we include that information as well. Last of all, we're going to include information about spread. Since we haven't talked about the other measures of spread, we will only include information about the range, saying that the later class has a smaller range or the earlier class has a larger range. Either one of those use the comparison words. We also once again include the numbers. Next, we're going to create a stem plot, and we're going to use our height data in our class data to create the stem plot. So the first thing that we need to do is figure out what our minimum value is, and our minimum value is 156 centimeters. Our maximum value in the data is 201 centimeters. So we're going to need to make sure that our stems start at 156 and end at, or I should say start in the 150s and end at the 2, 0. And so you'll see exactly what I mean when we set up our stem. So let's start with that. And we will start with a straight stem plot. So our stems are going to be 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, and 2, 0. And we're going to draw a line to indicate this is where our stem is, and then our leaves are going to be from there over. So if we have our data sorted, it makes it a tiny bit easier, of course. I'm going to go ahead and start listing our values. We have 156 is our smallest value, so this is just going to have a 6 in it. Whoops. A 6. And then the next value, the next largest value, I should say, is 159.38. So that is going to be 159. We're going to round it to 159. Then we have a few values in the 160s. So the first one is 160. The next one is 160. As you scroll through, we've got another 160. And 162.56 is going to go in as 163. Then we have a 164 and a 165, a 165.1, or two 165.1s. Then we have a 166, a 167, a 168. And then we move on to the 170s. So I'm going to ask you to pause the video, go through the rest of the data, graphing your stem plot. We've already got the stem, so you just need to include the leaves. And turn the video back on when you have graphed all of your data. We've got all of our data graphed, and we did have to round some of it, however. We can see shape-wise, we've got a unimodal, one peak, and it appears to be slightly right skewed. So a little bit more, well, it's approximately symmetric. Only one more column on the right-hand side than on the left-hand side. The benefit of the stem plot is while we can see the shape, we can still calculate the mean, the median, etc., other numerical summaries, because we have the original data as part of our graph. Now, what we do notice about this particular stem plot is we don't really have many bars. We've got 6 bars, and maybe our data is too tall. So what we decide to do in this case is split the stems. And so that means we're going to redo the stem and leaf plot, but instead of having one line for 15, we're going to have 2 lines for 15. So we're going to have 15, 15, and on the top line, it's going to include 0 to 4. On the bottom line, it's going to go 5 through 9. And that's going to be repeated for all of the other stems. So let's set that up, and then we will regraph our data on the split stem and leaf plot. So here we've got our split stem and leaf plot with 2 lines for each of the tens places. And we have, you can see we didn't have any in the 150s that were below 156. So that row is empty. We can see that we have a slightly different shape now. It still appears mostly unimodal, definitely right skewed, because we can see a little bit more detail. And in this case, we have a possible outlier. We suspect 201 might be an outlier. The other thing that we've included on this one that we forgot to include on our previous stem and leaf plot is the key. So now we have a key that shows 1,6 line 4 equals 174 centimeters tall. So this is how the stem and leaf plot works. Once again, we have the ability to calculate all the numerical summary we want because we're still capturing the original data. The only thing we need to remember is we did need to round it to get it into this form. That brings us to a check for understanding on the next page. So I'm gonna, again, recommend you turn off the video, you work through this check for understanding, check your answers in the back of your textbook, and turn the video back on when you're ready to resume taking notes. We're going to take a look at another type of graph now, and you'll see similarities between the three, the dot plots, the stem and leaf plots, and the histograms. When we look at shape, we're looking at the left to right, lower numbers to larger numbers, what we see, how many peaks we see, etc. The last type of quantitative graph we're going to look at is going to be a little bit of a departure from these three. But for now, let's just talk about histograms. And the first thing that we want to be able to do is take a look at the data. So we're going to use the sleep data from our class survey, and we're going to organize the data into a frequency table. Now, one of the things that is very useful about histograms is we can group data together. So we know that our smallest value is 3.5 and our largest value is 11, and this is hours of sleep. So what we're going to do is we're going to group together the data in some way that appears to be meaningful between the probably 3 and 11 hours. So let's start out with that, and then we'll create a frequency table and then tally our data. So here's the setup of our frequency table. Once again, we organize our data this way first, and then we draw the histogram. And I've added columns for relative frequency and cumulative frequency, so we can draw a relative frequency histogram and a cumulative frequency histogram. Now, just a reminder that we have to break up our data or group it together in some way. And you can see that the first line includes all of the 3 and above up to not including 4, up to 4 but not including 4. So we're going to go ahead and put down the frequency. Once again, go back to your class data and fill in the table associated with the frequency column. We've got the frequency in, and now we can calculate the relative frequency. So in order to calculate the relative frequency, remember, we have to take our total number of pieces of data, how many do we have altogether, and we're going to divide each frequency by the total frequency. We have a total of 37 pieces of data, so each one of these is going to be 1 out of, in this case, 37, so our relative frequency is... So we do all the division and we fill up our relative frequency column. If we graph frequency or we graph relative frequency, we're going to have exactly the same shape. However, if we look at cumulative frequency, that's going to look a little bit different. So when we graph cumulative frequency, we're going to start by putting in the first value, and then we're going to add on the subsequent values. So from 3 to 4, we have 1. From 4 to 5, we have 1, but from 3 to 5, altogether we have 2. And we're going to continue to add on the frequency each time until we get to our total frequency, which we know should be 37. And that's our cumulative frequency. So now this is going to look different because this is going to be like a stair step up, 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 up until we get to our total frequency. We've got our frequency tables down because we did do a little bit extra. We're going to now draw our histograms. And we're going to start out just with a frequency histogram, which is going to be the first column of frequency. While not very beautiful, these are my axes. You'll notice that I have the marked on the horizontal axis, which is the hours of sleep. I have the center value for the bar, and going up in the vertical direction is the frequency. So the next thing that we're going to do is start creating the bars associated with our histogram to demonstrate the frequency of each one. So to begin with, we're going to have 2 bars of frequency 1 each between 3 and 5 hours of sleep. Okay, so here is our frequency histogram. You can see that I have drawn the bars in different colors just so that you can distinguish between them. We have a label for both of our axes. We are scaled on both of our axes, and we have drawn our bars on both of our bars indicating the frequency. So the height of the bar indicates, but we can also include what the height is so that we can provide that information. And when we do this, we also see that we have some gaps in our data. So we would be able to do a description, a GSOX type description of the data that we have. Once again, this is the frequency histogram. Next, we'll do the relative frequency histogram, just so that you can see what that looks like, but it's going to be very similar. Here we've got the relative frequency histogram, and you can see it looks exactly the same. The only thing that's different is the scale. So next, we will create the cumulative frequency histogram, and that one will definitely look different. So turn the video off, create your horizontal scale, and then turn the video back on so that you can see and copy down the cumulative frequency histogram. Okay, we've got our cumulative frequency histogram, and you can see that it looks like stair steps going up. It shows the change of the frequency from one class or group or bin to another. And just as a reminder, when we see this, we know that this really means, it goes from 3 here to 4 here, but a value of 4 would be included in this column. All right, so much for our histograms. Let's see where we stand now. Before I forget, we cannot look at a cumulative frequency histogram and label this as left skewed because it's cumulative. So it's always going to have this shape. So don't think of it that way. And we will learn how to create histograms in the calculator in class. That brings us to another check for understanding. So once again, you're going to work on this check for understanding. Check your answers in the back of the textbook in the solutions section, and then you will carry on in class and work on the practice problems for section 2 of chapter 1, displaying quantitative data with graphs. See you back for section 3.